In this video, we'll discuss problems and conceptual exercises of chapter 3 from the book James Walker. So in this question, we are given that the police car travels at a speed of 38.0 meter per second due east in pursuit of a vehicle that is traveling at a speed of 33.5 meter per second due east. So let us try to represent it on a figure. So let this be our east direction. So the police car, so the vector will be, so this is the velocity of the police car relative to ground, which we are given to be 38.0 meter per second, and it's in the east direction. So this direction we have taken to be east. Now next, the vehicle is traveling at a speed of 33.5. okay, so this would be, we can represent it with a different vector. So this is our velocity of the vehicle relative to ground, which we are given to be 33.5 meter per second. Okay, now we need to solve two parts from this question. In the first part, we need to find the velocity of the vehicle relative to the car. Okay, so velocity of the vehicle relative to the police car. This is what we need to calculate, right? Now we can write that the velocity of the vehicle relative to police car, this should be equals to velocity of vehicle relative to ground plus the velocity of ground relative to police car. And if you have any confusion that how we are able to write this, you can view my previous videos where I have discussed the relative motion, and for that you can click on the bell icon. Okay, now this thing we know, this is here, and this thing we don't, this is VGP, but we know VPG, so this would be negative of, we can write this is negative of VPG. We can write this way also, because VPG is negative of VGP, right? So we can write this way. Now it's pretty simple. So this is, we have the magnitude of speed, the velocity is 33.5 meter per second. So this is 33.5 meter per second, and it's in the east direction. So we can take a unit vector along the east direction to be x cap. So this would be x cap minus, this is VPG is 38.0 meter per second x cap. Now from here we'll get the answer to be minus 4.5 meter per second x cap. So this is the velocity of the vehicle relative to the police car, and this negative sign shows that is just the opposite to the east direction, which is the west. So this the velocity would be in the west direction. We can represent it on the figure also. This will be the velocity of the vehicle relative to the police car. So this was the solution for the A part. Now next we can solve the B part, where we need to find what is the velocity of the police car relative to the vehicle. So velocity of the police car relative to vehicle, so this would be opposite to this. We can write negative of VP, and this thing we have already calculated, we can plug it here. So negative of minus 4.5 meter per second x cap. So this comes out to be as 4.5 meter per second x cap. So this will be the solution for the B part. This is VPV. So here in this question, it is given that in a hurry to catch your flight, you encounter a moving walkway which is 61 meter and its speed relative to the ground is 2.2 meter per second. So the velocity of the walkway relative to ground is 2.2 meter per second. Now next it says if it takes 49 seconds to cover 61 meter while walking on the ground, then how much time it will take for you to cover the same distance on the walkway? And we can assume that you walk with the same speed on the walkway as you do on the ground. So basically from this data we can calculate one thing, the velocity of yours velocity with respect to the walkway. So your velocity with respect to the walkway will be equals to the distance covered by you divided by the time taken. So distance covered is 61 meter and time taken is 49 seconds. So this will be equals to 1.24 meter per second. And we are assuming that you're moving in this direction, which is x cap. Right? So this we can write as x cap. Similarly, VWG, this would be equals to 2.2 meter per second x cap. It's the velocity of the walkway relative to ground is also in the same direction, x. We have to calculate the time taken by you to cover the same distance on the walkway. Okay. So for that we need to calculate the yours velocity, the velocity of the person basically relative to the ground. So this would be VYW plus VWG. We can write this way. Now this is, we have a 1.24 meter per second x cap plus this is 2.2 meter per second x cap. So this will be equals to 3.44 meter per second x cap. Now this is the velocity of a person, which in this case is you, relative to the ground. Now it's pretty simple. So time taken by you to cover the distance, which is 61 meter, divided by the speed, which is 3.44 meter per second. We know that time is distance over speed. This is in meters. Now we can solve this by using our calculator and we'll get the answer to be 18 seconds. So this time you will take to cover the 61 meter on the walkway. Now initially, if you compare the results, we can say that when you are not using the walkway, you take 49 seconds to cover 61 meter. But when you use the walkway, you will take only 18 seconds to cover the same distance. Therefore, you can conclude that the moving walkway decreased your time of travel from 49 seconds to 18 seconds. Now, this is our next question. It's a little bit tricky question, so pay attention to the video. So the question says that the pilot of an airplane wishes to fly in the north direction. So he wants to fly in the north direction like this. So this is the velocity of the plane relative to ground. But there is a wind blowing at a speed of 65 km per hour towards the east direction. So wind is blowing in the east direction like this with a velocity of 65 km per hour. Now in the first part they are asking in what direction relative to the north the pilot should head her plane if its speed relative to air is 340 km per hour. So this is the velocity of the plane relative to air. It is 340 km per hour, but we don't know the direction. This is what we have to find. Okay, and this is what the velocity of the air relative to ground. Now by the concept that we studied in the relative motion, we can write that the velocity of the plane relative to ground, this will be equals to the sum of velocity of the plane relative to air plus the velocity of air relative to ground. So this thing is a combination of these two vectors. Now this vector we know this is this. Now, but we don't know the direction of this vector, and sum of these two vectors is represented by this vector. So I can do one thing. I can take this vector to here. So I can write this is the velocity of the air relative to ground. I have not changed its direction, not changed its magnitude, just from this position to this position. Now think, what should be the direction of this vector? And if you have any confusion, you can first see my videos where I've discussed how to add vectors, subtract vectors graphically. Okay, so this should be the direction for the velocity PA, this thing. This is the velocity of plane relative to the air. Because if you add these two vectors, this one and this one, you'll get a new vector which is VPG, which is also depicted from this equation. Okay, now it's pretty simple. We need to calculate this angle theta. The magnitude of this is 65 kilometers per hour, and for this we have 340 kilometer per hour, and this angle is 90 degree. So you can use our trigonometric formulas to find this angle theta. You can simply write that sine theta, this would be the perpendicular over the hypotenuse. Perpendicular we have VAG, hypotenuse we have VPA. So from here, theta would be equals to sine inverse VAG over VPA. Now we can put the values. So theta would be equals to sine inverse. Now VAG we have 65, VPA we have 340. On further solving, we'll get this answer to be nearly 11 degrees. So this angle theta is 11 degrees west of north. Is west of north. This was the answer for the A part. Now next, in the B part, we need to draw a vector diagram that illustrates your result in part A, which we have already drawn. This is the vector diagram. So this will be the answer for the B part. Now next, in the C part, it says that if the pilot decreases the airspeed of the plane but still wants to head towards the north, should the angle in part B be increased or decreased? So what it is saying, that if this speed is decreased, this 340 kilometers per hour, if this speed is decreased, then what would be the effect of this speed on this angle theta? Will it increase, will it decrease? This is what they are asking in the C part. Okay, now it's pretty simple. If the speed is decreased, this is what they are saying, if the speed is decreased, then the theta should increase so that the pilot can move towards the north direction. And why? You can see from this equation, if this speed is decreased, this overall thing will increase, and if this increases, the theta will increase. Therefore, theta increases when the speed decreases, and this speed is speed of plane relative to air. If this speed is decreased. So if this decreases, the theta should increase.